In the previous presentation, we had discussion on a capacitor. Now in this presentation, we will be discussing some important points about the capacitor, in which the first one is, for DC sources, the capacitor will act like an open circuit, or simply we can say that capacitor stop DC current. So by DC sources, we means that for which the terminal voltage is constant. And we know that the current through the capacitor is equals to C dV divided by dt. So the voltage here in this case is constant, so the rate of the voltage will be equals to 0. So the current is in this case is equals to 0. So it means that capacitor do not allows DC current. To understand this point, let's take an example in which we have a capacitor which is connected across a DC voltage source. So initially when this switch is open, there is no net positive and negative charges on the plate. So as at the instant when this switch is closed, so the positive terminal of this voltage source will attract electron from the upper plate, and the negative terminal will repel electron towards the bottom plate. So as a result, the positive charges will be established on the upper plate and the negative charges will be established on the bottom plate. Now at the instant when the voltage across the plate of this capacitor, let's say V, is equals to the voltage of this DC voltage source, so the current flow will stop. The capacitor will no more allow any DC current through it. Now moving towards the second point, which states that, so for an AC sources, the capacitor will act like a short circuit, or capacitor allows AC current. So as we know that the rate of voltage across any voltage source is equals to constant. So it repeats itself after equal interval of time, so the rate in this case is constant. So for the positive half cycle, let's say the polarity is like this. So the positive terminal of this source will attract electron from the upper plate of this capacitor. So as a result, the positive charges will be established on the upper plate, and the negative terminal of this source will repel electron towards the bottom plate. So as a result, the negative charges will be established on the bottom plate. Now at the moment when the polarity changes from positive towards the negative, so the polarity will change from positive towards the negative and from negative towards the positive. So the positive terminal will attract the stored electron from this bottom plate, and the negative charges will repel electron towards this positive plate. So as a result, there will be no charge for a full cycle. So for a full cycle of this voltage source, there will be no charge stored on this capacitor or across these two parallel plates. So this process will be continue until we remove this source from the capacitor, and there will be no charge stored on the plate of this capacitor, and the capacitor will allow AC through it. Now moving towards the third point, which states that capacitor do not allow any sudden changes in voltage. So by any sudden changes, we means that for which dt is approaches to 0, and the changes in voltage in this case is finite. So dV in this case is finite. So from the equation of a capacitor, we know that I is equals to C dV by dt. So dV in this case is finite, so C dV is finite in this case, and dt is approaching to 0 because there is a sudden changes in voltage. So the current in this case is infinite, and it is impossible because it is violating the law of conservation of energy, the law of conservation of energy, which states that the energy cannot be created nor destroyed. So the sudden changes in voltage is impractical. So it's all for today's presentation. If you have any doubt, ask in the comment section. See you in the next one.